As usual, we always start our meeting with code of ethics. So may I please?
Can you hold on? I think people are still joining in, please.
Oh, sure. Sorry.
I think because a lot of people were expecting, so they're just coming in. So they just open the gates right now. Another 2 minutes, 3 minutes. Thanks.
So very good evening, my fellow Ishraites and all you lovely people from our fraternity. A very warm welcome on behalf of Ishrae. As per our tradition, we start our meeting with code of ethics. So may I please request Kundan to kindly display the code of ethics, please. Yeah. In this Ishrae meeting, we will act with care, dignity, and consideration, upholding all values of trust, teamwork, meritocracy, and justice. We shall not exploit the society's forum for any commercial or personal gains and shall avoid all real or perceived conflict of interest that our thoughts, words, and action shall besmirch the image and standing of Ishrae. So friends, once again, a very warm welcome to all of you. Today is a very important day where we launch our Evapcal. And without taking much ado, let me talk a little about Ishrae. You know, for those who are not aware what Ishrae is all about. Ishrae is the Indian Society of Heating, Refrigerating and Air Conditioning Engineers. It was formed in 1981. Ladies and gentlemen, we are celebrating Ishrae at 40th year of this lovely association, which spreads across India to 44 different chapters and sub-chapters. We reach out to more than 150 plus colleges, and today we reach out to more than 27,000 plus members with more than 114 international members. Last year we did around 1,500 programs, ladies and gentlemen, in a year. That amounts to almost 5 programs a day. At this very moment when we are doing this program, there are 4 other programs which are happening at various parts of the country. And that's what is the reach of Ishrae. We disseminate knowledge and we ensure that our industry is updated with the latest trends and latest development that happens in the field of HVAC and R. And today is one such day. And let me start with our technical chair, Mr. Vishal Kapoor, a presidential member. Mr. Vishal Kapoor is a mechanical engineer from IIT Roorkee and MBA from FMS Delhi. He has more than 24 years of industry experience. Managing Director of Mayo HVAC Systems Private Limited, a large HVAC contracting and servicing company doing projects all over East and North India. Everyone knows what kind of stature he carries in Ishrae. At Ishrae, he has served as president in the Society of 1718 and is current national chair of Technical Committee, International Advocacy, and chair of COVID-19 Task Force. Besides, he's vice president of Ishrae East India chapter and president of Rata Kolkata chapter and board member of IQGM. Without much ado, let me invite Mr. Vishal Kapoor to talk about today. Vishalji, over to you.
Thank you very much, Vihir, for this wonderful introduction to this evening as well as to myself. It's actually a wonderful day to be present over here on an occasion where we're launching possibly one of the best possible tools that Ishrae could bring to you. And I wanted to share with all of you, the listeners, as to how do we reach this process? What are the activities that Ishrae is doing on the technical front? Because it's very important for all of you to understand that what Ishrae is doing today is going to benefit each one of you in whatever position you are, in whichever activity you are. It's finally going to reach out to each one of you. So it's our duty to understand what we do, how we do it, and possibly look at contributing towards it in the days and years ahead. Now, one of the strongest pillars of Ishrae are the technical activities, which is driven by a committee called the Ishrae Technical Committee. And a part of this technical committee is something what we have called as technical groups. Now, these technical groups, also called as TGs, are basically subject matter depending on various activities. Today, we have around 30 technical groups which are activated and fully functional. Each TG focuses on one subject matter, ranging from basics like heat load psychrometry, going to detail like applications of data centers and healthcare, going into equipment like chillers and pumps and airing handling units, going into processes, and a variety of applications, including commissioning to servicing to refrigeration, cold chain, etc. Now, these TGs, which comprises of anything from 8 to 80 members, are basically Ishrae volunteers who are devoting their time, who are subject matter experts in that particular field, and their tasks listed out include writing publications, developing books such as guidebooks, guidelines, fundamentals, basics, handbooks, position papers, white papers, anything that is required for that particular subject. They are into developing training workshops, short-term, long-term certified basis workshops. They are organizing webinars, which are short duration, 1 hour, 2 hour regular webinars. They are into developing specific projects. I'll come a little bit more on that. They are into developing and conducting research. Today, Ishrae partners with some leading institutions across the country. And along with them, we help develop and improve the technology, the systems, the solutions. For example, currently we're doing close to around 5 research projects all over the country with premium institutions, also at times in partnership with the Department of Science and Technology. These technical groups also help in developing standards. Ishrae, for those you would not know, has developed quite a few standards in the past, including on indoor environment quality, IEQ, on chillers, on VRF, AHUs, filters, commissioning, which has got launched recently, and many more are on the preparation board on the annual to come in the next year or 2 years ahead. So all in all, anything and everything to do with that particular subject is driven by this TG. Let's look at some examples. We have a TG on UVGI, which is a very, very current topic, a very important topic for the industry, specific to the times we're living in. This TG has developed now a position paper on UVGI technologies with a specific focus on COVID virus. And this is going to be launched next Friday at the very same time. And I can easily say at the same venue because we are all now digital. So next Friday, 6 p.m., again, Ishrae will have a big day when we launch the UVGI position paper, and you would all be invited to come in and join over there. That is one of the examples of what a TG is doing. We have a TG which is on basics on heat loads. And that TG has now written a book called Basics of Air Conditioning, a 150-page book, which is going to talk everything about the very, very fundamentals of air conditioning, and a phenomenal book for those who are starting the careers or journey in this industry, or those who want to brush up their knowledge and be in touch with times. This book is going to be launched in the coming month in September. We have a TG on thermal comfort. Again, a very, very important subject from all angles, whether it's from the current epidemic times or from energy efficiency and reducing cost, etc. A very, very important activity. This TG has developed a white paper on thermal comfort. That thermal comfort white paper is going to be launched in mid-September. Again, all of you will be invited for that. We have a very active TG on healthcare, a very, very important subject, touching each one of us today, tomorrow, or at some point in our lives. And we want healthcare to have the best possible systems, the safest systems operating over there. This TG, which also incidentally has a couple of doctors on board to advise, and we need their side of the knowledge also. This TG has developed a book which is going to be close to 400 pages guidebook on HVAC and automation, fire life safety in healthcare applications. This book is going to be launched in early December for all of you. These are just some examples of the kind of technical work, technical activities, technical groups are doing for you. we just recently launched an air purifier guidebook, which was developed by our indoor air quality technical group. This air purifier guidebook is available for you. You can just go onto our website, ishrae.in, and buy that book. Again, details everything that you would want to know about what to look for when you're buying an air purifier. Coming to today's topic, Evapcal. This is being developed by a TG, a combination of two TGs. One TG is the TG of evaporative cooling, obviously Evapcal. So evaporative cooling TG comes into happening over there, and also partnered with another TG, which is the TG on thermal comfort. So we have two TGs that have come together to develop this wonderful software tool with the help of MNIT. And this tool today is going to be presented in front of you. I'm not going to be talking much about this. I am very excited about this tool because it's something which is unique, possibly one of the first in the world, very, very, very customized to Indian conditions, usable for every possible activity, whether you are a designer or a service provider or a contracting company, it is useful for everyone. And this is the kind of work that is being developed by our TGs. These are not easy jobs. Some of these activities take 2 years, 1 year, a lot of hours. And remember, we are all volunteers. It's not that it's a professional body. It is a professional body, but not a professionals being paid for doing this kind of work. We are all doing it for a love, for a passion for this industry, to ensure that the future ahead is far, far more better, ethically clear, good, and technically correct. So this is what we're doing over here. And I would look forward to more and more people joining hands with Ishrae, volunteering to serve on technical groups. You can go on a website and volunteer to serve on a technical group if you are from that subject line and are an expert and consider yourself of good knowledge in that subject. So look forward to getting in touch with more and more people. Spread the message across. If you want Ishrae to do more technical activities, if you have ideas, please write to us. We will surely try and work in that direction. Join us for our future events, like next Friday for the UVGI position paper. It's all of these are very, very wonderful technical topics, current topics of interest to everyone. And I'm thanking everyone who's joined today. And the next hour and a half ahead of you is going to be a wonderfully engaging session. And over to Mihir, back to you. Thank you very much.
Thank you, Vishal, for giving that wonderful overview of the kind of activities what we do at Ishrae. I'm really proud to say that I'm a fellow Ishrae. It makes a lot of prudence in the kind of activity what we guys are doing, and the way we are lapping up at every possible opportunity of any development of any new technologies. So really proud of you guys of kind of work what is happening at the technical groups. So friends, let me now get the next speaker, who is our national president. And he's none other than Mr. Mathur. He's BSc and BTech and MBA in Marketing and Finance from Kolkata University, having more than 33 years of experience in the field of HVACR, specializing in industrial ventilation and fume extraction system. He's Director Operations at Aircon India Incorporated, an HVACR contracting company and one of the leading partners in the country for carrier air conditioning, Wipro Water and Canon Office automation products, with over more than 450 employees and INR 60 crores of turnover. At Ishrae, he's a current national president, committee member of Ishrae COVID Task Force, marketing honors and awards, finance and publications, etc. Without much ado, over to you, Mr. Mathur.
Thank you, Mihir, and good evening, everyone, and welcome to the launch show of Evapcal. You have heard from Mihir a little bit about the shape and size of Ishrae, and also Vishal has given you a fairly broad overview of the technical work that we do. I will take you through a very small presentation trying to briefly explain about the other activities also that Ishrae does. Allow me to share my screen, just a minute. Okay, is that visible?
Yes, sir, visible.
Yeah, okay, so you have already heard that we are in the 40th year of our journey. We are still young and we will be, going a long way from here. Our vision is to be recognized as one of the leading body involving, in doing technical work, training, and research on HVACR industry and serving the building services industry. Our mission is to promote the goals of the society so that the general public is benefited. And we do this through chapters, and we organize events, and activities, conferences, seminars, based on, how to protect environment, improve indoor air quality, conserve energy, and continuously provide education to our members as well as students from the HVACR fraternity, and also do certification programs, give career guidance to the students at local colleges and also tertiary institutions. So that's the shape and size of Ishrae. We are present in 44 chapters today in India. Soon would be having some chapters abroad also in the neighboring countries. We almost 13,500 plus members, 250 student chapters, and 11,000 plus student members. I mean, these figures are always, these are very dynamic figures and changing very fast, very random. This presentation may be a little dated that way. So what are our key objectives? Yes, the technical content, you heard a lot about that from Vishal. Research and innovation, skill development, education is one of our main pillars, I would say, apart from the technical. These are the two pillars on which the society is standing: development of standards and, of course, student activities. So what do we do? I mean, in all these areas, 40 plus publications that has been rolled out. You've heard about some from Vishal, some which are coming up, but there are already existing 40 publications. There are Ishrae research grants have been given worth 12.3 million for the 5 research that is going on, and previously also. There's this journal, which is bi-monthly journal, which comes out. It's almost got 1,200 technical articles published in it. 15,000 e-downloads have happened, and circulation, every issue is circulated to the members and to all important industry stalwarts. 500 plus students have received student project grants from us. We have developed standards on IQ, VRF, chiller, AHU, filtration, and also HVAC commissioning systems. Weather data book is there for 250 cities across India, Sri Lanka, Bangladesh, and Nepal. And you heard from Vishal about the technical groups, 30 technical groups, more than 1,500 volunteers serving them. You can be one of them, of course. And the Ishrae COVID document, which was brought out last year and is getting updated. The knowledge bank, where anyone can log into ishrae.in and download or see these articles, the journal articles, the training videos, the technical blogs, case studies, and also the dictionary. There are a lot of jargons that are used in the HVACR industry. So if you're not sure of that, you can go and find them for yourself. I was talking about education and the certification programs we do, and this is what we all we give to all of you. There is an advanced diploma course that has been conducted by Ishrae. It's a 4-month course, and it is, it's been very widely accepted by the industry. This diploma, it makes you ready for the industry. Actually, it can be taken by students, it can be taken by young engineers, it can be also taken by experienced engineers to kind of refresh, because we keep on refreshing this course and adding the new new contents about the new developments, the new technologies that have come into play. And of course, we have certified courses, ICP, on clean room, on air conditioning design, air conditioning service, commissioning, essentials of drafting, and there are courses which are coming up on refrigeration, healthcare, ventilation, cold storage, and central plant services. There are e-learning opportunities also. You can have them sitting at your home, at your leisure, and you can download the courses, go through it, give an examination, and get a certificate. And this certificate is given a lot of, it's a lot of acceptance from the industry. Also, we go down to the absolute grassroots level, people who help us build our reputation, the technicians who slog it out on the field. We train them on unitary products, on VRF, also on advanced systems. And there are distinguished lecturer programs, which is about 50 programs and some workshops. This is what we do for the students. I mentioned about the students' activities. So already there are about 400 technical talks that has been carried out, some 100+ industry visits to make the students get a feel of how the industries are, how they are organized, how they operate, so that when they come to them, they join us, they don't get a shock. They are well acquainted with it. So then we give the student project grants that I've already spoken of. We have already given it to 500 students. Then there are product showcases in multiple locations, where kind of all equipments are put and they're shown so that they get familiar with the equipments. It's kind of a mini lab kind of a thing where you see some equipments which are working also. And then we organize quiz programs at every level, at the chapter level, then at national level, regional level, and the national level. The A-Quest, which is the national level quiz, which is a very kind of a well-known quiz for in the industry. And the design competitions. The student design competition, recently the hackathon has been launched, which is also a kind of a design competition. And then we reach out. We reach out to government, we connect with government, we jointly work with them, they appreciate the work, we collaborate with government to kind of develop so many systems, technologies, and standards, and so on and so forth. Industry engagement is the same way. Associate societies, you've seen almost 42 MOUs we have, domestic and international put together, and of course, academy interaction through our student student chapters and also beyond that. Searcho is the HVACR dictionary. If you want to look for anything about the HVACR industry, you are looking for a product, you're looking for some service, you are looking for kind of some work to get done, this is a place where you can find the people or the industry or the companies that is engaged in this in those services and products, and you can connect with them. Acrex is the largest show in South Asia. The industry is growing, and we don't miss out in showcasing the industry once a year. All of us, we come. It's like the Sangam, it's like the Mahakumbh of the HVACR society. This is the 6th largest show of the world and the largest in South Asia. Similarly, we have RefCold, which is one of the largest shows in refrigeration, and that's also kind of very well accepted by the government and the industry. Urjavaran is one of the national programs which has been conducted in 31 locations, more than 5,000 delegates there. There are many other national programs which are driven by the chapters like the ACRICON, FRACON, Confluence, TechFest, Symposia, and so on and so forth. And Urjavaran has gone international also. We have conducted Urjavaran in Sri Lanka, Bangladesh, Nepal, Kenya, and we are spreading our wings and we are thinking of further locations. So this is our theme for this year, Lakshya. What is Lakshya? It's lifelong learning. It's adapt to best practices, knowledge enhancement, share and serve. That's what we do. Harmonious growth. We have been growing harmoniously and we will yearn for excellence and then finally accomplish. So that's what is Ishrae in a nutshell. Too short a time to explain the mammoth work that this society does and through the volunteers that we have. And so thank you for being with us. Join us if you are still not a part of this society. I can assure you it will be a very, very rewarding journey. So this is our connect. You can make a note of it and get in touch with us. Thank you. Thank you, Mihir.
Thank you so much, Amitabh, and a belated happy birthday to you from all of us. And
Thank
I think
you.
this is
Thank you.
perhaps the best gift what you are getting in return today for launch of Evapcal.
Absolutely.
Right.
Absolutely.
And on that note, we are more than now 210 people who are joining this amazing program. So thank you very much, guys, for this astounding response. And by taking the program forward, let me get on to the next speaker. Kundan, may I please request you to share the screen? It is none other than Dr. Jyotirmay Mathur, please. Dr. Mathur is a PhD from University of Essen, Germany, MTech from IIT Delhi, India, head of Incubation Center of Malviya Institute, Malviya National Institute of Technology, Jaipur, MNIT. He has supervised 12 PhD theses, published 75 research papers. It is referred international journals and has presented more than 150 papers, talks, international seminars, and conferences, besides authoring, editing 5 books in the field of energy. Dr. Mathur, you have given practically one paper for the independent year of India. So thank you so much. DID Research Ambassador for promoting Indo-German research collaboration for the year 2014, Fellow of IBPSA for award of fellow status given by International Building Performance Stimulations Association year 2019. Ishrae Distinguished Service Award for service to professional body given by Indian Society of Heating, Refrigerating and Air Conditioning Engineer for the year 2020. Without taking much ado, over to you, Dr. Mathur.
Thank you, Mihir. Very good evening, everyone. And it's really a unique occasion for me. As an academician, I am proud to showcase industry-academia collaboration. And through this exercise, we have tried to do one, how industry-academia collaboration can culminate into useful knowledge-based tools. Two, how two TGs can collaborate and have a fruitful outcome which can serve the society members. So I will not take much time in giving a background. Straight away, let me start covering what I've been asked to cover. So basically this tool, Evapcal, is having a long journey in the background of it. So thermal comfort, that's why I'm trying to cover thermal comfort in evaporative cooled environment. Whenever we are talking about thermal comfort, usually it is either in naturally ventilated buildings. You cannot call evaporative cooled buildings as naturally ventilated buildings purely, okay, because natural ventilation is something different than evaporative cooled. Air conditioned buildings are also not evaporative cooled buildings in terms of thermal comfort, because the perception, the exposure and other things are different. So definitely thermal comfort is to be looked at in a slightly different manner when we are talking about evaporatively cooled environment. And then how we felt that there is a need of developing a tool and how we embarked upon this journey. So this is just the broad outline of my presentation today. So starting with what is thermal comfort, all of you know because you serve the HVAC and R industry, and mostly we design our systems for having the comfortable conditions inside, but still there are two internationally practiced or referred sources for thermal comfort definition. One is Ishrae 55, which is very commonly used in green buildings or wherever. But the mother standard is ISO 7730, which is not talked about very frequently, but yes, ISO standards are considered to be the mother standards, especially because India is a signatory of a treaty in which we are obliged to follow ISO standards wherever they exist after some Indianization, if necessary. So the condition of mind which expresses satisfaction with the thermal environment is nothing but thermal comfort. And as the definition says, and as it is very clearly written in the standards also, that it is based upon a subjective evaluation, because something at which I am comfortable, you may not be comfortable in the same situation. And therefore, there cannot be a magic formula for evaluation. Each individual may have a different perception about thermal comfort. And internationally, if we talk about thermal comfort, two of the standards I have already named, but there is also another European standard, which is EN 15291. And these three standards are quite frequently used and quite widely used globally. And in the figure which I have shown on the right-hand side, there are different factors, different influencing factors that control thermal comfort. It may be ceiling temperature, it may be wall temperature, it may be exhaust air, it may be outside air, it may be evaporation that is happening within the room, it may be clothing, it may be your activity also. So all of them put together, they influence your thermal comfort, and it is not just the air temperature or humidity. So that is how we see thermal comfort, and the term which is used to quantify thermal comfort or evaluate thermal comfort at least is operative temperature, which is, if I put it very simply, average temperature of the air temperature and the temperature of your surroundings. So if I put all the surfaces that are surrounding you at some temperature, so the temperature is X, the air temperature is Y, X plus Y divided by 2 is basically, in a very simplified manner, operative temperature. That is what is the meaning, because the surfaces also have influence on our comfort because of the radiation they release. So ASHRAE 55 is also having a long journey behind it. And we have tried to capture this journey just to give a background of thermal comfort, that this is an evolving field, and it is still evolving, and it will keep evolving because our perception, our habituation, and our expectation of thermal comfort is changing day by day. So if you look at way back 1966 thermal comfort zone in ASHRAE, the zone looks somewhat like this. So there were, and no important thing is, yes, there have been two distinctly different zones. One was the winter zone for thermal comfort, another was a summer zone for thermal comfort, and there is obviously an overlap. So this is very clearly coming right from the beginning of thermal comfort journey in ASHRAE standards. Then a modification in this zone came in 1992, and in 1995 version of thermal comfort standard from ASHRAE, this zone took a slight change. Not slight change, I would say there was significant change. This slant line had gone, and now the zones are kind of trapezoidal, parallelogram kind of zones, and these are there. So from 1992 onwards, this shape of thermal comfort zone got changed. In 2004, another big change came, and now you can see a sawtooth kind of structure coming on the top side of it, and therefore this was a significant change that came in 2004 in thermal comfort of ASHRAE. Then that sawtooth shape again went away, and now in 2010 version onwards, we have again a flat line on the top of this thermal comfort zone, which is represented by the shaded lines that I'm having on the slides. So this is the thermal comfort, which got modified in 2010 again, and now in 2013 again this got modified. If you notice, if you allow me to go back, the zone was ending at about 35% relative humidity at the bottom. Okay, so this zone is floating in air, and now this zone came little closer to Earth. So the bottom line or the bottom limit of the relative humidity was getting relaxed, and people were expecting in ASHRAE standard a lower humidity as well. And then the recent versions say that there is no limit. Okay, and there is another factor which has started coming now is the clothing. 1 klo is the official clothing, and 0.5 clothing is the summer clothing. So with reference to clothing also means basically 2004 onwards, thermal adaptive thermal comfort concept started coming and influencing the thermal comfort zone. So, and then they started from 2013 onwards, they said that yes, we have two ways of defining thermal comfort limits. One is when 90% of the people subjected to a set of conditions, they express their satisfaction. And another is when we are not so sensitive about everybody, 80% people they express. So obviously, when 80% people are considered to be under satisfactory limit, then the limits are going to be much relaxed. So the spectrum of, or the bandwidth of temperature that got widened, and this started coming from 2013 onwards. And then again, 2013 onwards till 2020, the last version, they are also saying that yes, there is a need of adjusting the thermal comfort limit as per the MET value, which is the activity value, as per the clothing, and as per the airspeed also. If you look at the table on the left hand side, the bottommost entry greater than 0.2 meter per second, that is for the higher air velocity limit. ISO standard right from the beginning is starting about higher air velocity, and the graph at the bottom is talking about the air velocity adjustment. So the way how we read this is you identify the air velocity on the y-axis, you draw a line to the relevant curve out of the 5 curves, which is the most relevant curve. Wherever this line curve cuts this curve, you drop the line on the x-axis. Whatever the value comes on the x-axis is the delta T you can add to the higher temperature limit of thermal comfort, which you otherwise have at still air condition. So say if I have 25 degrees or 26 degrees as the limit, if I am having air velocity and if the dropping is at 3 degrees, I add 3 degrees to 26 degrees and 29 degrees become my limit. That is the approach of ISO. Why I am explaining this is the same approach we have adopted in our Ishrae standard. So EN standard is pretty much aligned with ISO standard. So we have Ishrae standard in which the same air velocity adjustment approach is written. We have another important standard or code, shall I say, is NBC. And in NBC, we have India-based. Now, this is the first time when India-based research started coming into standards. And in fact, the top 2 equations are coming from the IMEC model, which was released by CEPT University. And the air-conditioned space equation was coming by the PhD work of the first student here at MNIT in 2007, Shivraj Dhaka. He found through rigorous analysis this equation, and these found space in NBC 2016, which is the latest version so far. But still, if I ask you a question, which one applies to evaporatively cooled buildings, there is no clear-cut answer. Because none of these, probably to the best of my knowledge, had data collection happening from evaporatively cooled buildings. And that is where I'm starting to build the context of our evaporative cool Evapcal. This is what is there in Ishrae IEQ standard. Again, for the first time, we have this air velocity adjustment, which is given in ISO standard, appearing in any of the country-specific standards. And that is why we are still very proud of how we brought about this IEQ standard. In addition to this air velocity standard and the temperature limits, which are aligned with NBC 2016 as well, we also gave some temperature, radiative temperature asymmetry limits, which are there coming from ISO and EN standards. These are mention is there in Ishrae standard, but not very clearly. So we took it from ISO and EN standards, and now the Ishrae standard is covering all these aspects very clearly. There is another dimension of using the thermal comfort zone is the building bioclimatic design chart. And the building bioclimatic design charts, they have a history starting in 1963. 1963 building bioclimatic design charts, they were developed basically to assist designers of buildings, including architects, and the purpose was to help them identify which is the passive or active strategy that is going to bring the indoor conditions comfortable. So this was the comfort zone used by them, and you can see that air velocity adjustment limits are also there. Then came the much used and much referred by building bioclimatic design chart by Givoni in 1969, the year of my birth. Okay, but the database that they used was primarily from US, Europe, and Israel. And you can see that there is the blue color line, which says that this is the zone in which if your ambient conditions are existing, that is good for being addressed through evaporative cooling. So basically, if most of your ambient condition points are in this zone, evaporative cooling is the best suited strategy for conditioning your building. This is how this chart is to be interpreted. And so is the zone defined for all other design strategies, high thermal mass, night ventilation, and this and that, whatever. Okay, so this was the motivation point for going further. And then there is a very widely used tool, which is called Climate Consultant, that is released by UC Berkeley. And so far, that is the very widely used tool in India also. Despite the fact that the climatic zone, the comfort zone defined here is not India specific. But yes, that is the only thing which people can use and they refer. How this is to be read is, again, the points in this zone are representing the ambient condition, and then these polygons are referring to every passive strategy. If maximum number of points lie in certain polygon, that particular strategy is useful for you. So what we did was, we had conducted about 5,000 occupant satisfaction survey in different parts of the country. Primarily, they were there in Jaipur, obviously, because of ease of doing it. But yes, in different parts also, we collected sample. We also included evaporatively cooled buildings, 80% acceptable limit, and 20% samples we reserved for validating the point. So this was the zone that, based upon the literature, based upon our findings, and based upon the scientific method, including the graphical method mentioned in Ishrae 55, we could, with the help of the reference number 7, you can see, that in this 7 and 8, in fact, both, we had Carnegie Mellon University as our partner in developing this. Professor Vivian, she is one of the leading experts, and she works very closely with the authors of Ishrae 55, Gail Brager and others. So she helped us in getting this zone developed, first of all. But this was developed upon the international data only. What we did was we had 5,000 plus data with us, and our research scholars further after Shivraj, Sanjay Kumar and Priyam Tiwari, they helped us in extending this work, and we arrived at this polygon, which was India specific polygon for lower air velocities less than 0.5 meter per second. Okay, so we validated this. As I said, 20% of the data we had kept reserved for validation. So we validated this polygon, and then only we moved further. Then what we did was, there is a method of modifying the climatic zone, the comfort zone in Ishrae. How you can modify this polygon if your air velocity is high. So we took the case of the base polygon and we applied that method to higher air velocity up to 1 meter per second. We found that the polygon gets shifted to higher air velocity, which is obvious also that people will be more comfortable at higher temperature at higher air velocity, and even little higher humidity can also be tolerated. And so was the effect coming in this polygon. After having the cause effect analysis done, we applied this to Indian polygon, and we also found the same shift. But yes, the humidity limit, which in the international database polygon was coming as 90%, in India it was coming as 80%. And the way in which this was done was that if in any direction from the center of this polygon, if you move 80% of the points, if they are lying in the polygon, wherever the 80% points are there, you draw a line there only and let 20% points remain outside the polygon. Because if you try to cover every point, your polygon will be too large and it would lose its meaning. We also applied this to higher air velocity, because in India we have higher air velocity, and in evaporatively cooled environment, this aspect is very important, because in evaporative cooling we have higher velocities as compared to the air conditioned environment. So this polygon kept shifting on right side towards higher temperature limits, and this is where it started ending. Then what we did was, based upon our thermal comfort survey, we started identifying that what are the ambient conditions under which the resultant condition can be brought inside the thermal comfort polygon. And then these two lines, they were brought, which means on Indian thermal comfort behavior, using the Indian data, if your ambient conditions are lying within these limits, you are likely to have acceptable system behavior. And that is what we did. And then we extended this polygon further for higher air velocities, and all the three limits, they were identified. So there was a lot of analytical work which was carried out. And actually this entire story is very short, the work done by 3 PhD scholars starting from 2007 till last year when Priyam completed her PhD. Then fortunately, Ishrae granted us a PG project. PG project was for development of a bioclimatic design chart for India specific conditions. And once again, I am very proud to say that Ishrae is always coming forward for supporting such industry useful research. And if you can see that even the look and feel we purposely kept quite similar to the climate consultant tool by UCB, because people are already comfortable with that. So this is the Indian polygon that we had developed. And then we have the green line, which is basically representing the evaporative cooling zone. So now what you can have is, you can connect your weather file with this. Nishant will tell you how exactly to do that. You can connect your weather file with that, because that has all the ambient conditions. All the points are plotted on this graph automatically. And then these green points, all these green points, they tell you how many hours in a year you can have satisfactory performance by your evaporative cool system. So, and if the points are lying above these green limits, the systems are, so the evaporative cooling system is not going to be sufficient, as you can see in this graph. And similarly, we have 2 different polygons, one for direct cooling, another is indirect cooling. And therefore, so coming to the last part of my presentation, so why we should treat evaporative cooling in a very specific manner and very different manner, and especially in terms of thermal comfort as well as system design. First of all, higher air velocities are there. We all know that the higher air evaporative cooling environment is having higher air velocity. I have also touched it earlier. People who are using evaporative cooling, evaporative systems, they are also getting habituated for higher air, standing higher air relative humidity. So the RH tolerance of people who sit in evaporatively cooled environment is little higher. that is there. Then we have mostly, you would find that the ambient conditions are dry wherever we recommend evaporative cooling, and that is not a brainer, we all know. Because of a lot of fresh air, the CO2 levels are also better, lower CO2 levels, as close as to the ambient level. So they are there, but yes, there is a drawback of that. Usually there is a higher background noise as compared to our regular air conditioning systems. But yes, now nicely designed systems nowadays can also address that. So this is just why evaporative cooling systems are different. Why we thought that we should develop this Evapcal, because one was that when we are doing this, we ourselves were stuck up with the question that, okay, we have told somebody that evaporative cooling is going to be the best suited way for conditioning your, making your building comfortable or occupants comfortable. So what? Is just telling that this is the way, this is the solution sufficient, or we should help people design the system also? And in fact, this thought came from Nishant, whom I can call father of this Evapcal tool. Okay, he said, yes, Dr. Mathur, we have concluded that evaporative cooling is best for this place. So what? Can I also help? Can I also extend this tool to help this person design and interpret the cause effect better? So first of all, what we saw was that the evaporative cooling systems were very commonly designed by using rule of thumb. And we found that, yes, there is a great difference between the theoretical design and what was being practiced by rule of thumb. Okay. Water calculations, which is very important. Now, with water crisis, we have a lot of water shortage problem coming up. Therefore, water calculation is becoming very, very critical. Comparison of direct indirect, because direct indirect cooling systems are coming and competing. So we should have a tool, which we should have a way of comparing these two alternatives. Absence of visualization, unless you visualize, a user who's non-technical normally is visualizing that what is going to be the effect, probably he would not accept evaporative cooling as an option. And therefore, we embarked upon the journey of developing this tool. I would still keep it as a secret that what is there in the tool, and because that is the privilege of Nishant. So here I would stop. So I'm sorry if I have taken more time than as compared to what was allocated to me, but that is all because how passionate I feel about this topic. I'm sorry for that. And thank you very much.
Not at all, Dr. Mathur. I mean, you are so passionate about the entire subject. That's what it says. And thank you so much for that lovely insight. Now, let me, without taking much time, let me invite father of this particular tool, Mr. Nishant Gupta. He's a mechanical engineer from Bhopal University, MBA in Marketing Management from Institute of Management Studies, Indore. He has more than 22 years of experience in the field of heating, ventilation, and air conditioning. Managing Director at Degree Day Private Limited, Indore. His company is engaged in providing HVAC design solutions and manufacturing of Greencon brand air cooling and air distribution products. He's past president of Ishrae Western India chapter, and at Ishrae currently serving as vice president technical and chairing the standard committee and evaporative cooling standard. Without much ado, Nishantji, over to you.
Thank you, Mihir, and thank you, everyone. And thank you for waiting for such a long time. But let me tell you, the wait would not be wasted. It will be worth every minute and second that you've spent. And I'll take pleasure to introduce you to the tool which we proudly call as Evapcal. Well, as Dr. Mathur and few other speakers have already briefed the journey about it, the main objective to bring this tool was to uplift the evaporative air cooling industry standards. Now, if not India, probably nobody else. We had been blindly following the West and using air conditioning system. Not that they are not good. Probably they are the best solution for a particular case. But there are a huge number of hours in a year where we can do the things because of the kind of ambient weather that we are blessed with, to live with evaporative cooling, which will consume very, very less energy to reach to the thermal comfort. Now, the common questions that came across all of you while you're designing, using is that, is my place right for air cooling? I'm staying in Mumbai, I'm staying in Delhi, in Chennai, in various places. Does air cooling work? What temperature can I expect in the space? People talk of saturated efficiency of the product. I'm not interested. I want to know that what would be the temperature in the space that I would be breathing in.
how many months, days, or even hours can I be comfortable using this kind of systems? And when you communicate about being comfortable, now the definition would be different for different persons. That is where the concept of thermal comfort has been integrated into the system, so that you can define that this is what the thermal comfort is. We're not talking about an individual thermal comfort because it varies based on person to person, their expectation. But as Dr. Mathur mentioned, by a large analysis and study, which has been concluded that these many temperature and humidity conditions are being considered as a comfortable condition. What type of air cooling is right? People come up with single stage, two stage, indirect evaporative cooling, which is the right solution for your particular application. Most importantly, what is the right capacity? There had been cases where somebody quotes for X CFM of air, which is required to bring you a thermal comfort, while Y person would quote something else. There is no basis that you can compare, and people would have their own whims and fancies, or maybe their own experiences that they would fathom upon. What is the kind of energy saving potential if you're using this? Is there a way that you can document and verify that? What is the water consumption? There has been cases where people falsely communicate that our equipment consumes less water, hence it is better, while it could be vice versa as well. So is it worth what the claims are being promoted in the market? How do you select that? Should you go for air conditioning or for air cooling or for a hybrid system and deploy both at the same time, generate a very good return on the investment? So is there a way that we can take an informed decision, unbiased decision? These are the questions which brought in, the concept of Evapcal. And as an engineer, we are being, known to assume the data if we don't have. And as they say that sometimes you make right decisions, while many times you make your decisions sound right. So once you've taken a decision that, okay, I want to cool the space using 20 HNs per hour, 10 HNs per hour, 60 HNs per hour, then you'll do whatever is required to ensure that what you've communicated is right. We are trying to mitigate all those kind of questions. And I would like to thank none other than Dr. Jyotirmay Mathur. It was his work and his research teamwork who had brought us to the level where we are today. And to Raj and Khyati, who's actively working in coding the requirements which was there and imbibing all the concepts. I need to mention Dr. Priyam Tiwari, as Dr. Mathur said, that she was the last person who was working on this concept of thermal comfort. Mr. Vishal Gupta, who was also instrumental in giving the inputs, and all the members of both the technical groups who had given their various inputs. The process started back in last year around the same time in September 2020, and I just realized it's been almost 11 months that we've been working on this tool, and both of the committee members defined the task to be taken in October 20. The concept note was created by Khyati on 28th October based on various discussions, and the tool was named as Evapcal to calculate the evaporative cooling process and the systems. The first version of it was released on 22nd January after a lot of meetings, internal discussions, and more than 20 to 25 updates in the software were done since then till the time that we released it on a beta version on 16th June to both the technical group members. They were subject matter experts on thermal comfort and evaporative cooling. The tool was shared with many consultants, contractors, manufacturers, obtained their inputs, and whatever possible within this domain were included before we come to the day today where we are with you to launch this software today. Okay, now a very important note that this will be a work in progress always. We would be coming out with various versions in times to come, improvising on whatever best we can do. Today, the software is available only for Windows-based system. You need to have a Windows operating system. You'll get an .exe file, which you can download from the link that we'll inform that how you'll get it after today's call. So please stay back. Once you download that, you need to ensure that your Windows is having at least 64-bit architecture. I'm kind of focusing on this because unless you have these parameters being met, you might not be able to, run the software smoothly. So please ensure that in the system that you're operating it conforms to this requirement. It would be useful for all the HVAC MEP designers. It will be useful for even the architects and people, those who would like to do simulations and take a decision that, yes, I have to go in for this decision. of evaporative cooling. It will be very, very useful for all the contractors who do design build job or who have to conform to the conditions, all the manufacturers who would size their equipment and promote their products and brochures, all the PMCs and end users who are the influencers, who are the end users, to understand how it works. Now, this tool not only calculates the capacity which is required to provide the thermal comfort, also give you a complete analysis in various 2D, 3D formats and graph for the entire year or for your operating hours. Not only for direct evaporative cooling, but also only for indirect evaporative cooling, for two-stage evaporative cooling, and it does it for all the major cities that we have the weather data filed for, and in fact goes beyond India, and you can select any EPW file which is available on an open platform from across the globe, any city, upload the data and start using it. A very quick salient features before we actually deep dive into the software. This software has pre-installed hourly weather data file of all the major Indian cities, which includes the wind velocity, the temperature, RH for each and every hour for the entire year. It calculates the exact air capacity based on the input of the heat load, which is there in that application. You need to provide that information. It gives you a comparison on achievable thermal comfort between various strategies. So you might like to use indirect evaporative cooling or a direct or a hybrid two-stage. It will give you all those comparison on a click of a button. So it will be that easy for you to take a call. It will provide you the flexibility to define which kind of thermal comfort you want. There could be people who would say that, no, I want comfort as good as air conditioning. No problem. You might select those tight boundaries as are defined in ASHRAE thermal comfort and see that how many hours in 8760 hours you feel comfortable. While if you relax your requirements, or you may define that, okay, I just need to ensure that my room temperature does not exceed 28 degrees C, 27 degrees C. And you'll get to know that how many hours you'll be able to achieve thermal comfort into it. It gives you a flexibility to select the operating hours. You might not be interested to know the entire year's performance. For a restaurant owner, might be able to understand only from evening 4 to maybe 12 p.m. What is the 12 a.m. I would say, what is the time of comfort that you can achieve? You get all those flexibility while using the software. It will give you an hourly analysis, not only on a psychometric chart, but also on a 3D, 2D graphs. It gives you the peak water consumption, what will be the peak requirement on per hour basis, and the power consumption based on the input that you give, and gives a very wonderful customized report for your own company, for giving all the details which is required, which can be used as a basis of design to give your offer or selection or order. The project outcome can be exported in Excel files, so you can do many understanding iteration analysis from that. It can give you a PDF report. You can save it as a file and later use it for any further, any kind of changes. Now, there are certain disclaimers which needs to be, very carefully taken care of. It does not currently include the heat load calculations. That has to be done using any third-party software, Excel file, or any software that you use. Once you do that, you need to put in that data, and it will take care of the sensible heat load part of it. In case of indirect evaporative cooling system, the heat exchange between secondary air and primary air is assumed to be equal to the heat exchange between the water and secondary air. Outdoor design conditions at 0.4% design day range has been auto-fed, but you can change it now from 1% to 2% based on your requirement. And you need to be very, very careful about the input values, because GIGO falls in. You put in the garbage and you get out with the garbage output. So please be careful, and it'll just give you a right direction. It does not confirm because of the inside temperature condition, because it will vary based on further system designs and the installation and the manufacturer's product. But it gives you a very clear idea on what you can expect, and you can take up a decision that whether you want to go in further on it or not. So without further wait, let's take a dip, and I'm requesting Khyati to please switch on your desktop and show that how the software runs. Khyati, if you can share your screen. And I'm also requesting, meanwhile, everyone, those who have any questions, may please type on the question in the question answer section, and we'll try to answer as much as possible if the time permits. So thank you. Once you download this software, and we'll show you how to download the software after the end of this demonstration, you would be welcomed with a screen, which is this, and you'll start selecting a city. So Khyati, if you can select the city, and you'll find all the cities listed in the drop-down menu, and select Indore, my own hometown, and see that how the performance goes in. So once you select the city, automatically the data would be fetched in of this city for entire 8760 hours. Press OK, it will give you all the information, what all you need to feed. I'll tell you about it. Khyati, just put the project name. It is important because the design basis report comes out. Put it as XYZ Limited. It can be your client's name so that you can refer back to him. You might like to give a reference number. You may put Khyati 1234 as a project reference number, and might like to give a revision R0. All these have a bearing. Put it as R0. You might like to have the person's name mentioned. Put it as Rakesh, somebody in your office who had designed the system and you would like to refer back to him. And it is submitted by your company. So you may put it as Degree Day Private Limited, my company, who's designing on this system and would like to explore the systems. Now we are talking of a building geometry, which could be very different. So put it in a very, very easy way. Have area mentioned as 1000 square feet. It could be in any geometrical progression. And let's have the height considered as 10 feet of the space. Now you'll see that as we have put indoor condition, the ambient condition has popped up. It is designed at 40.2, which is the peak condition, which falls at 99.6% times. You can change the design range to 1%. If you do 1%, Khyati, you'll see that now it has changed to 39.5. That means 99% times you would be falling within this temperature and wet bulb range. So you can select whichever you want to. Now you can define that what is the maximum allowable indoor condition. So Khyati, you might put 28 degree, for example. Your client has told that I want a system which should not exceed 28 degree, and put RHS, for example, say 70% for the sake of it. Now you need to do a separate heat load calculation for 1000 square feet, which will inculcate all kind of building geometry, the thermal conductivity of the walls, equipment load, so on and so forth. Let us assume 1000 square feet would have about, say, 7 tons of air conditioning, which is about 84,000 BTU. Let's assume that, no, put sensible as 70,000 BTU hours, assuming 70, and assuming 14,000 as a 84,000 as a total. So that means 14,000 is going into the sensible heat load. Now you might like to change the units, and there is an option of SI unit on the top where you can click it and all the data would get changed into the SI unit. Or you can again go back, unclick it and come back to the FPS unit. Now I'm right now doing it for direct evaporative cooling. So just select direct evaporative cooling. Now any manufacturer that you are intending to buy the product would tell you that what is the saturated efficiency of his machine. That means that how much wet the air can be made using the equipment. Let's consider 85%, which is a very reasonable figure for any good quality product. And if there is any ducting which is going through a long direction, you can have a temperature rise in the ductwork mentioned as, say, 0.5 degree, which will be increased, or you might like to put it as 0, depending upon the ducting network. And you press calculate. Now, the moment you calculate, it does the calculation for the entire year and calculates and inform you that what is the amount of air quantity which is required in that space to achieve the desired result that you are wanting to. So it will give you, now it shows that you need 8,627 CFM of air. Your supply air temperature would be 23.5. And Khyati, if you can just remove this 0.5 degree of ductwork, the additional temperature, and again calculate, you would find that now this 23.5 has dropped down to maybe 23 degrees. And your supply air capacity also might slightly drop down. And now you see that has dropped down to 7757. And the temperature that you expect in the space coming in is 23. And the humidity would be 77%. Air changes for this area is working out to be 46. And the peak water requirements without the bleed off loss is 95 liters per hour. Now, you might be interested to know that what is my indoor space temperature? I'm not interested in the supplier condition. Before you may do so, Khyati, you can press on any of the buttons of the ambient. So you can click on, say, ambient DBT of 2D heat map. It will indicate you that what is the kind of city that you're working upon, your ambient design condition in indoor, how many time or at what time. So say in April, at 2 o'clock, you will find that the temperature goes around 35 to 40 degree. The darkest red indicates that's exceeding 40, 41, 42, and rest of the times it is comfortable. You can close this, Kathy. Similarly, you can see the wet bulb temperature also of the ambient, and you can also see it in 3D. So let's see the ambient wet bulb temperature in a 3D heat map. So it is indicating the same data in temperature, in terms of temperature, hour of the day, year or month of the year, and you'll be able to see that how the ambient design conditions are. You can close it. Now you can also see that what is my room conditions in similar ways. Can you please switch it off and again come back to the indoor air temperature? Close this annual ambient data. Yeah, please run the indoor 3D heat map. So you can see those analysis by a simple click of a button for entire 8760 hours and view it that what is the kind of conditions that will be available. You can very well extract the entire data in an Excel file of all those 8760 hours and do further analysis with a precise number if you'd like to. We can go back. Now, once you've done this, you go to next. So it takes you to the next chart, and here you can further do iterations. So, okay, now you'll see on the left-hand column, this is the data that we have done the analysis for the entire year. On the top, you find annual drop-down button. So you can select that whether you want to use it only for summers or monsoons or spring, autumn, winter, or a custom time. We can go back. Let's do it for the entire year only right now. But if you select any custom data, you can select the month. You want it from January to maybe, select it for custom, for example. Let's show it across. You go in a custom. Yeah, now select from, we want to know from, okay, February till, it's okay, February till May. I'm interested to know that how does it perform in February to May? And I want to know that for each day of the month. So from 1st to 31st, but I want to know that how does it perform from evening 4 till 24. So you select maybe 16 hours. So it starts from 16 hours to 24 hours. Okay. You can also mention that since you know now what is the air cooling capacity, you can mention the kilowatt. So assume 1.1 kilowatt for that kind of capacity. And in case you're doing with air conditioning, whether you're doing with chilled water, VRV, what is the power consumption on IKW per TR? So let's assume 0.9 kilowatt per TR. You're comparing it with a very efficient VRV system. Now you press OK. Once you do this OK, it'll process and let you know that you are now considering only 1080 hours of a year. And out of that, using direct evaporative cooling, 943 hours is where you would be reaching in your comfort zone. This blue line on a psychometric chart indicates your defined limits. You said that I don't want beyond 28 degree. I don't want the RH to go beyond 75%. This is what the requirements is. So how many hours you'd be comfortable? Now let's compare it with Ishrae 55. You just select on the top Ishrae 55 thermal comfort chart and you negate what you have called for. Now you're looking at that I want a perfect condition. So only 356 hours is where as per Ishrae you would be comfortable. But we are in India, we are more widely considering our Indian condition. So let's see the Indian composite bioclimatic comfort zone, the chart which Dr. Mathur explained, which encompasses all the conditions of Indian weather data. Now you'll see again that out of 1080 hours, about 974 hours you are comfortable. Let's see what is the impact on room air velocity. So as we know that in evaporative cooler, if you increase the air velocity, you add these fan circulators or you increase the supply air speed from the grills. Let's select 0.5 to 1. And you will see that in place of now 974 hours, you are comfortable actually for 987 hours. Now we'll go to Kathy, you can select the annual data. Let's select from custom to annual. So you can do all those iterations and see that what is the impact. Okay, now calculate for this. This is indicating on a psychometric chart the process also. It's showing the start point. Your ambient design was 40 degree and about say 17%, 18% RH. Because you had 85% saturated efficiency, the line goes to the point where the supplier condition was. And then it takes up the heat of the space based on the heat load that you've mentioned. And the next point shows you the room temperature condition. So it does it for each and every hours. Out of 8760 hours, you'll find that 7,293 hours, you would very well remain within this comfort zone, which is about 83% of the data. And at the bottom, it is also showing that what is your ambient air condition that you've considered, what is your room supply air conditions, and the indoor air conditions that you can achieve. Let's go on the next. This gives you a summary that 1000 square feet and 10 feet height, the sensible heat load that was there, what is the capacity that you want, what is the air changes which is coming out, how many hours you'd be comfortable and how many hours you might require alternate strategies, what is the peak water consumption on that point of the time, what is your peak power consumption, how much would be the power consumption if you're using an air conditioning system, and what is the energy saving potential. Now, once you've done that work, let's save this as a project. So once you save it, it gets saved as a file for Evapcal and automatically generates a folder in C drive by Evapcal projects and mentioning the name of the project with the revision number XYZ R0 DEC, which is our direct evaporative cooling. Okay. You can now export the data in an Excel file also. Kathy, if you can do that for me, just export the data as an Excel file. Once you do that, in the same folder, it will save that data as an Excel file. Now this project report has been saved as an Excel. Can you also help to generate a report on PDF format, Kathy? Generate the report. So put it as 3D. Select, you can select that what kind of graphs you want. We are selecting that we want to showcase the 3D graphs in our design report. Now, if you can go back on your system, Kathy, and open that folder where these files are getting saved. So we can see that what all is there for you to be taken forward for. Once you've saved all this data, you can anytime come back to the project, open up your old file, do the iteration. And if you try to save the file with the iteration, it will say that you need to revise it because there's already a file which is existing of that name. That is where that revision 1, 2, 3 would help you. And a separate file would be saved by that name. Kathy, please open that PDF report now. Now this PDF report would draw all the information which you have seen in this and would form a design basis report, which can very well be used to be presented along with your offer, with your justification of the system that you're using, or a owner or a PMC or an architect can take an informed decision. Kathy, can you please help to open up that file? You can share the screen and show that where the desktop, how the files are being saved. Okay, you've already opened. So if you can just go back on the folder, Kathy, it will be better that we see. Yeah, on the C drive, you find this Evapcal project folder has been opened up. Now you can double click. And this is the Excel report, PDF report. So let's open the PDF report or Excel report. Let's open the Excel reports first. Yeah, double click it. Now this is the project name XYZ. That's your client name. And this is the revision R0. This will give you all the information which was mentioned over there. And you as a designer or a green building consultant or architect would like to do a lot of further fine tuning from this. So like you can see now all those data which was mentioned is available over here. You can go on annual data, Kathy, please. There are different tabs. There are 3 tabs. You would find the annual data, which indicates the entire 8760 hours calculation. And in case you've opted for a custom operation, it will indicate those many hours. And now it shows for each day, each hour, starting on 1st January, 1 o'clock, the ambient was 17 degree, wet bulb temperature was XYZ, and so on and so forth. So all the data of supplier condition, room condition, ambient condition, RH, entire data would be available for entire 8760 hours. It's fine, Kathy, you can just go down, scroll down and show that it's available for the entire 8760 hours. Similarly, this data is available for the operating hours. In this case, we have gone back and used the entire year. That's how it's showing the same. But if you would have done it for those many months, it would have only selected for those limited hours and shown you the data of that. Okay, Kathy, let's go back to the PDF file and see that how the report is now visible now. Yeah, if you can go on the full screen mode. So this is the A4 size printout that you can take out. It shows that this report has been generated using Evapcal software, which is jointly developed by MNIT and Ishrae. The design report is indicating the thermal comfort level, which is possible using evaporative cooling strategies for your client XYZ Limited by your company. And if you can go on the next page, please. Next page. So this indicates again the date and the time. It auto stamps the time that we have run it, indicates the revision number, indicates the project reference number, extracts the ambient design conditions of DBT, WBT, allows a user to understand that what is the maximum allowable condition he is allowed for, what is the operating period. Kathy, you can go a little bloated, just increase the font size. It might not be visible. Yeah, so it indicates that operating, go down. So indicates the operating period, operating hours, what strategy we have used, direct, indirect, or two-stage, what comfort standard we are using, what is the air velocity that we have selected. Next page, please. Okay, so on the next page, again, you get the calculation summary report, that what was the area. This is a report which even your competition or anybody would be referring to. He knows that what is the basis that you have calculated, and he can do the similar simulations and see that all of you are on the same page. Gives a apple to apple comparison to everyone, and then you can take forward your decision. Go back, go a little down. So based on this input, now it gives a recommendation that the above calculation indicates that endothermal comfort is possible for 83% of the time, and additionally it also provides 100% fresh air. In case of balance time, you want still comfort conditions, you might like to use alternate strategies like air conditioning systems or any kind of active thermal comfort strategies. Next page, please. It gives you again on a pie chart that what is the comfort hours and uncomfortable hours, give you room air condition either in 3D or 2D based on your selection, both for the temperature and RH for the entire year, each hour of the day. Also indicates, go down, also indicates the same data on a psychometric analysis for each and every hour, that how the process has happened, what is your design point, what is your room temperature, what is your supplier conditions. Next page, please. And also gives a disclaimer that what all are the bases that has been considered in this work. With this, we can close down and we can go back to another simulation, and maybe we can take it in Q&A. We can do similar calculation. If you can go back, Khyati, open a saved project. So you can again select an open project which you've already saved, go back to the same folder, and you'd find the same file which was available and saved, and you can start from there. Open it now. So it will now come back to the same data, and we can also now, for a minute, before we end this, you can go for a two-stage selection, Khyati, and see that what is the impact that is coming up. So we've kept, and now here you need to also mention, so let's put as 55% indirect evaporative cooling. It will also have certain efficiencies. So you select this, and now the earlier data, which was calling for 7,700 CFM, you would see that if you're going for two-stage evaporative cooling, your air quantity has now reduced to achieve the similar kind of thermal comfort. And in place of 80 CFM, the conditions now calls for only 4,100 CFM. So you can now save on your ducting and heights and so on and so forth. Gives you 18.1 degree supplier condition. Go next. And you can see that how many hours you would be comfortable using this kind of system. So now it indicates that this is the comfort hours that you would be able to achieve using two-stage evaporative. You can change the air velocity again and see the impact, and again save the entire data into a revised file. So Khyati, you can go on the last slide and try to, or on the first slide, and let's try to save it on the same name, and you'll see that it will ask for you to save. Let's go on the first page now. Okay, sorry, on the last page, and save the report. On the last page, save the project, right? So now it says that this is saved as R0 TSEC. That is a two-stage evaporative cooling. If you would have done it for the same DEC, it would have asked you to change the revision number. so on and so forth. So it will ensure that your data gets saved and you're able to generate that information, which will help you take the informed decision. This is about the tool, and if you have any questions, we can take up that. Once we are done with the question answer sessions, I would invite our president to launch it and make it available for you so that you can download it. He'll explain you how you can receive this and start using it in your system. So over to you, Mihir Bhai.
Thank you so much, Nishantji. I think that was really very, very, very intense, and the kind of work which has gone behind. Kudos to each one of you, entire team who has worked and poured their heart into it. So let me, you want me to ask first the questions? There are quite a few questions.
I would request you to please invite Chandra sir.
Sure. Okay, so let me call on dais now Mr. N.S. Chandrasekhar. He's our president, national president-elect, a mechanical engineer from IIT Kanpur, certified energy auditor from Bureau of Energy Efficiency India, BE. He has over 38 years of experience in the field of heating, ventilation, and air conditioning. Partner consultant and certified energy auditor at Genex Consultant in city of Hyderabad. At Ishrae, he is a current national president-elect, recipient of Regional Service Award and Chapter Service Award by Ishrae. Over to you, Chandra sir.
Thank you, Mihir. Thank you very much. And very good evening to everybody. Great presentation. I think today is a great golden day for Ishrae and golden day for all the consultants, contractors, manufacturers, and users, and everybody who is involved in planning to use evaporative cooling, which, as explained by Dr. Mathur as well as by Nishant, that has got a lot of benefits within. But so far, we always thought, even I'm a consultant, I always thought there is a mystery in evaporative cooling where we think that we will get something, but we still not able to give in terms of a presentations what exactly people will get. And today we saw the wonderful charts which proved that we can prove it in theory, we can give a backup theory, we can give a presentation on what the conditions will be under various circumstances, and 2 TGs coming into picture, and Ishrae's weather chart of these various cities, which was done earlier, coming into full effect of combining evaporative cooling with this, and such a wonderful thing. So let me get on to the, without much ado, I think this has been explained by Dr. Mathur and Nishant so very well. And in case the questions are there, I will like to take up those questions and see whether we can, in this chat itself, in this discussion itself, we can answer your questions. There are some questions which have come on the question answer panel. I would request that everybody, if you have any more questions, please put your questions on the question answer panel. Before I get onto the question answer panel, I see a couple of hands raised. I would request the backend team to unmute Mr. Ramachandran, K. Ramachandran. I would, he has got something to say. So let us listen to him and then we can get on to the question answers. Backend team, please unmute Ramachandran. Ram? Mr. Ramachandran, can you hear us?
Chandra, can you hear me?
Yes, sir. Please go ahead.
Yeah. No, I don't have a question, but I want to mention something here. What you just said is absolutely right. Because when we were taught air conditioning in companies like Voltas, etc., we were very clearly told that if you want comfort condition, you have to go for air conditioning. You cannot go for evaporative cooling. But that is proven to be myth now. With the present knowledge stage, we can really use evaporative cooling in many projects. And what I have to say, with the present COVID situation, probably, and going forward also, probably a once through system with evaporative cooling may be much more acceptable to people than a recirculating type air conditioning system. So the importance of evaporative cooling is bound to increase, especially for assembly buildings, malls, etc., where large tonnages are working. Probably a well-designed evaporative cooling system in the right climate zone will be very, very useful, both for energy saving as well as a once through system. So the future of evaporative cooling is really very bright, and what we just saw as presented will go a very long way in designing a proper evaporative cooling system. That is all I have to say.
Thank you, Ramchandran. I think very well said. It's you put it very nicely to the audience, and it is wonderful to have such a tool. And this tool is going to be definitely used by everybody. I'm sure about it. I have one more hand raised, which is Mr. Madhukar. If you can, backend team can unmute Mr. Madhukar.
Sir, can you hear me?
Yes, Madhukar, please go ahead.
Good evening to all. I think it's just mind-boggling. Hats off to the team. I know there's been hours and hours and hours of tireless work that has gone into in getting this kind of a software out by the entire team at Ishrae, especially the TG group on evaporative cooling. Nishant and team, hats off to you. It's just I'm speechless actually to give the kind of effort that would have gone in. I mean, we have used several softwares to design our heat load. I don't think this lags behind anywhere. Perhaps it would go one step ahead of whatever software you have been using. It's crystal clear. Every layman can also still do this. And today, I think they proudly go around and start telling that Ishrae has found an alternative solution to air conditioning with energy saving, bringing in with a lot of green concerns to the fore. And I'm feeling extremely happy and proud to be a part of this Ishrae fraternity. And this is something which will take us a long way ahead in terms of where Ishrae stands. Hats off to the team once again, and well done, Nishant and team. Congratulations, all the best. It's one more feather in our cap.
Yeah, thank
you, sir.
Thanks, Madhukar. I will get on to the other questions which I have here. Is from Mr. Prakash Lohia. There is a question. Either Nishant or Dr. Mathur, one of you can take this. What is the effect of higher velocity on overall power consumption in case of higher velocity design? As the blower consumes more power, then refrigerant load will increase. Does this nullify with higher velocity?
So, Dr. Mathur, would you like to, or should I?
I think there is a problem on Dr. Mathur's system.
I'll take it up. Yeah. So as you would find in the software, when you change the air velocity in the space, you would find that the comfort level has changed. You can alter the capacity and see that what is the revised capacity which is coming. Say, for example, in case 1, you require 8,000 CFM to achieve what you want. In case 2, you require now 7,000 CFM. Based on your system static pressure, you would be able to eventually calculate that what is the energy saving potentials on the blower. Mind you, in terms of air conditioning, the blower power only consumes about 10% of the total power consumption, which a refrigeration system would consume, which is not the case in case of evaporative cooling. Here, the blower power might consume more than 90% of the energy, which would be required to run that system. So based on the application, you would be able to see that impact of the thermal comfort and do a very simple math calculation to identify what is the energy saving potential.
Thank you, Nishant.
In addition, Nishant, what Mr. Lohia is saying, if he operates at a lower temperature rather than operating at a higher air velocity with higher blower power, what is more economic in terms of energy? I think clearly it goes in favor of energy, air velocity, higher air velocity.
Without any second thoughts. Of course, I believe beyond thermal comfort, if you talk of IQ, higher velocity would have related concerns. So as long as the person is finding himself comfortable at that higher velocity, definitely the energy saving is much more over there.
Yeah, I would also like to add one more thing to that today, this is the first phase 1 of the development. You will find much more advances coming onto this development. This phase 1 is just a stepping stone. It's step 1. You can see, there is going to be step N. That is a level. It is really a thrilling and encouraging thing for everybody in this field. There is another question here by Mr. Durga BK. Does water quality affect the efficiency and performance of evaporative cooler?
Yes, sir, it does. Definitely it does. Probably this software does not take care into account those kind of works, but our group technical group is writing standards on this process, and it will also indicate a standard operating process and the kind of eventuality based on this. But this, to answer you, this software does not account for the water quality. It just talks about the requirement of the system.
Absolutely, that's correct. What you said. This is more of a calculation on the evaporative cooling. It's not on the performance of water, how it affects or anything like that. For that, we need to refer to other standards. Where do you get? There is a question from Mr. Satish Karan. Where do you get the heat load data from? Is it using heat load estimation software like HAP? I will answer that. Yes, you have to use a software like HAP or whatever way you calculate on that, because you need to feed in the sensible load and the total load onto this tool. So you need to find a method to calculate.
But there is a very important answer in this question, which also would answer another question somebody has posted. This is phase 1, as Chandra sir said, and it talks of only peak load. The moment we start using software like HAP, which our separate TG heat load is already working upon, and we intend to collaborate further with TG Thermal Comfort to develop an hourly heat load calculation, which can be inbuilt into it. The moment you do it, you would be able to actually analyze the exact water consumption for the entire year and exact energy consumption, so on and so forth. There'll be a lot of various outcomes that will come out once we integrate that. But currently it is just using the peak load conditions and considering that as a base heat load for the entire calculation, which has been mentioned in the disclaimer as well.
Exactly, like Mr. Vishal mentioned in the beginning, we have so many technical groups who are operating within Ishrae, and heat load is another technical group which is operating there. They are working on the software, so they are working on now that software along with this software, when it is integrated, you can have varying heat load conditions which is fed into that. There is a question by Mr. Dr. Gaurang saying that share the software link on our registered email, any academic version of software for training engineering students. I think
this software would be available for free for any and every Ishrae member. They can use it from across the globe. How do you get it is what, once it gets launched, our president would inform very shortly after the Q&A.
And the reason for keeping it free, Nishant, is very simple, that there is no cost of development to Ishrae. We proudly say that this is developed at zero cost to Ishrae, and therefore there is no cost going to be there for use of the software.
Yeah.
At the same time, it is important to inform that there is a dedicated resource which Ishrae has deployed to take care of any queries and answer it within the working hours. So you would be surely getting a good support of the software.
Yeah, thank you, Nishant. There is another question on estimated from Mr. Shankar Gime. He says that estimated active air conditioning capacity also needs to be calculated at 28 degrees centigrade or at 24 degrees centigrade to match sensible heat load in the evaporative calculation. I think this was answered even in the previous question. Yes, you need to calculate the heat load calculation, but once this is integrated with the software of heat load, probably that can take the points for all the hours which we are talking about. There is a question from Mr. Javed Siddiqui. Is it the same as that of CFD software?
No,
I don't think so. I don't think
it is not. It is not at all CFD.
You saw this software. Probably the question was put at a slightly earlier stage. I feel it is not. There is a message from Mr. Anshuman Dubey saying that great initiative, thumbs up. Yeah, there is a question from Sudipta Sanyal. What about annual energy and water consumption? Yeah, Dr. Mathur, I think you answered that, but you can.
Yeah, again, the annual energy consumption data and annual water consumption data can be calculated only once we have annual heat load plugged into the system. Yeah. Since we have the peak data plugged in, that's why we are talking of peak. So in phase 2, yes, you'll get it.
And Mr. Anshuman Dubey says, please provide software for use trial. I think you can just wait for the launch, which it will be launched. And if you're a Ishrae member, definitely you will be able to download it for free and you'll be able to use that. And there is a question from Mr. Mohammad Hussain. It says that it will be better if it shows surface temperature or occurring of surface conditions at a particular hour of the year. It will be better if it shows surface temperature or occurring surface condensations at particular hour of the year, it says.
Okay.
We can, Chandra, add all these things to the wish list.
No, we can take this point, what he has
But
given.
Our concern as possible. All the less and less people start using it. So we will note it down, but we'll go back to our committees and see if we can have a trade-off between usability, ease of use, and details as desired.
Today, I can say that this software is more aimed at a practical usage. What is important is what sort of a climate conditions that will will be present inside the conditioned area. We can predict something on that. We can also provide the graphs. I think today that's the first step which is taken. So we will note down your point and see whether how to do that. And how to get this software, I think that is already answered. You just wait for another few minutes. Is it feasible to get the project report in Word format or any editable format? I think it was answered, but anyway, Nishant, you can look into that.
Yeah, so it is available in Excel sheet and you can take it forward. The balance data comes in PDF. You can very well generate your own report separately if you want to.
And
but at Ishrae, we would not like to give editable.
Chandra, most of the questions that are coming, they are already mentioned under
chat.
Chandra,
yeah,
most of the questions that are coming, they are already covered under the user guide that has been developed, and the grants to the questions, they all are
okay.
covered.
There is
So
another
if
question.
you permit, we can.
Yeah, there is another question here which is saying that if we have selected higher capacity machine, can we back calculate the effect on the project?
So you have to do actually the iteration to reach to the number that you've selected to, and then you can do it, because we have to have one variable fixed. In the current case, we have defined the room temperature to be fixed. If we define the air capacity to be fixed, then the room temperature changes. So in the current model, it does not do it. You have to actually do your simulations, iterations, because normally a user would like to know the room temperature and not the air capacity, and it should work on that direction to achieve the comfort.
I'm not sure, Mihir, how much time I have more on this. Some more questions are there, if I can take them.
Sir, we can take them offline, and I think let's do the launch, because
yeah,
we have already crossed our stipulated times.
Yeah, there are some more questions, and I am thankful for everybody for posting the questions. I am sure our panel here will look into your questions, and we have your mail ID, and I would assure that definitely we will send answers to these questions. And I request our panel, please, and the backend team, please take a copy of these questions which are there, and let us make sure that we answer all our members. Today we have such a wonderful participation of close to about 200 plus people here, and this is excellent tool. I do not want anybody to go without their questions getting answered. So backend team, please make note of these questions and give it to Dr. Mathur and Nishant. We will definitely answer those questions. Thank you, Mihir, for this, and thank you, team, for wonderful work which you people have done. Over to you, Mihir.
Yes, sir. Thank you so much. So may I please request Amitabh to kindly launch this software. Chandra Saab, you can be also there, sir, please.
Sure, Mihir. That's would be an absolute pleasure. Wasn't that fantastic, ladies and gentlemen? Please join me to congratulate both the TGs, Thermal Comfort and Evaporative Cooling, who have enabled this. And today we have this tool with us. It's just a click away. I'll just take you through how we have to do this. And I'll again share my screen for that. So you have to go to ishrae.in. That is ishrae.in, ishrae.in. And here you get download Evapcal. Are you able to see that, Mihir?
Yes, yes, sir, able to see, sir. Please go ahead.
So download Evapcal, click on this, and you will be taken to the page of Evapcal. You have to go to the end, scroll down, and you will find Evapcal user manual. You can download the user manual by clicking this download Evapcal user manual. This will be a PDF user manual which will be downloaded on your computer. And this is for downloading the software. you have to click this and you will be taken to your login ID at ishrehq.in. And as you enter your membership, the ID and the login password, you will be going, and here you get download Evapcal software. So as you click this download, this software will be sitting on your computer, and you have to follow the steps one by one and install this and start using it. Absolutely free of cost. So that's it. Don't miss out this opportunity. This is an excellent tool, I would say, gifted by the TGs to us, all of us, and let's enjoy this. You have to just be an Ishrae member. So if you are not, you just have to join us. And not only this, you get an array of other things which will come on your way. So thank you very much. That's it. And it's an excellent, excellent, I would say work done by the TGs. Thank you. Thank you very much.
Thank you, team, and thank you, Amitabh. It is really wonderful to have this tool.
RTS, congratulations, team. Today, I can assure you that each one of us are feeling so proud. Vishanji, you may be father, but I think all of us have become either uncle or mama or chacha or whatever.
So none of us are fathers.
Phenomenal
It's
gift.
all collaborative efforts.
Absolutely. You've given a phenomenal gift to all the members of Ishrae, and I think many more. I'm very sure about it. It is a great service to the nation. Let me put it that way. Thank you. Thank you. Thank you so much.
Thank you.
Without taking now much ado, let me introduce now our National Secretary, Mr. Yogesh Thakkar. Mr. Yogesh Thakkar is a mechanical engineer and MBA from Institute of Management Development and Research, IMDR Pune. He has over 29 years of experience in the field of heating, ventilation, and air conditioning. Founder of Yogi Engineers, authorized sales and service dealers of Carrier Toshiba air conditioner. At Ishrae is a current National Secretary. He's a member of IGBC, Rotary Club, and FSCI. Over to you, Yogesh Bhai, for a vote of thanks.
Thank you, Mihir, for the kind introduction, and what a great evening for Ishrae. Let me just start congratulating our National President Amitabh and the whole Ishrae. Today, I am feeling proud of being a Ishrae member, and so must be all our committee members, all the national chairs, RDs, vice presidents. Each and every Ishrae member must be feeling proud about. And it's really a gift to the Ishrae members. Such a wonderful, wonderful gift to the Ishrae members. And this shows the standing of Ishrae as a pure technical body. We have seen Ishrae doing contribution to the technical part of the HVAC in a strong way, and it is making it stronger and stronger year over year. Let me firstly give a big thanks to the technical groups, the TG, the ITC, under the able leadership of Mr. Vishal Kapoor. A big congratulations to the whole team. A big round of applause, and ably supported by our Vice President, Mr. Nishant Gupta, supported by Jyotirmay ji, the whole team, the support team, Khyati, Raj, Samar. A lot of hard work, dedicated hard work has gone behind the preparation of this Evapcal. Let us all admit it is not a day, weeks, it is more than a year. Even post the whole software was prepared. Before launching, a lot of work had done, at least a 6 months work went behind it. So a big thanks to our RD West, Mr. Mihir, for doing the master of ceremony in a great way. And it was, the whole event was done by the program team. Mr. Hemant was there, and ably supported by the marketing team, Mr. Sandeep Galotra, the whole team. Ashu Gupta played a really important role in supporting all the marketing activity. Without the support of the IT team under the able leadership of Anuj Gupta, the whole software, the conceptualizing, loading, Anuj, great compliments to you and your team. So, and how can I forget not thanking our own team of the HQ office, Jitendra, Kundan, Ravi, Saloni, all HQ family, as I always call them. It was a great team effort. And a big thanks to all the participants who, it was a great number. We had got almost 600 registration and reaching a number of almost 200, which is a great number. And once again, a big congratulations to all of us for a great gift of Evapcal. And that's all from my side. Thank you. Good night.
Thank you, Yogesh Bhai. And with that, I think, guys, I think phenomenal. Looking forward to this great software, and I'm very sure great tool. It will be helpful to everyone. With that, a big thank you from Ishrae. Take care of yourselves. Stay safe. Good night. Shabak hai. Thank you.
Thank you, Nishant and Dr. Mathur. That was a wonderful gift on my birthday.
Thank you, sir. Thank you. It was a pleasure.
Most welcome.
Super.
Thank you very much. Bye. Good night.